Again, a very warm and good morning and cheerful good morning to my dear students. Again, I am back with a very new and important and interesting topic, which is known as the hypothalamus. The hypothalamus, as we all know, it is known as the master endocrine gland. This can be asked as an very important MCQ question in your final examination. So kindly note it down. The question can be which is known as the master endocrine gland, A. Hypothalamus, B. Pineal gland, C. Pituitary gland, or D. None of the above. Hypothalamus, it is the master endocrine gland. It secretes many releasing hormones due to which the particular hormones are released from the particular and specific gland. For example, the hypothalamus secretes the growth hormone releasing hormone due to which the anterior pituitary or the adenohypophysis secretes the growth hormone. Okay, so now moving on forward. I hope everything is clear up till now. So this is a flowchart depicting how and when the effects of the hypothalamus are being felt on the particular system. These effects are okay. These influences are the neural influences and the hormonal influences. These all influences and the effects on the particular systems are on the physiological activities of the human body. The neural influences are basically from the CNS. The hormonal influences are basically from the endocrinal glands. These influences come on the hypothalamus. Again, they effect have an effect on the hypothalamus, and from the hypothalamus, these effects go to the autonomic nervous system, to the limbic system, and to the endocrinal system. Understood, my dear friends? So moving on forward, functions. This is the most important part, understanding of the functions of the hypothalamus. Okay, the functions of the hypothalamus are autonomic nervous system regulation, hormone production. That means, as I told you, the for example, here you can quote the example of the growth hormone releasing hormone, and thereby from the anterior, the positive feedback mechanism goes to the pituitary gland, the anterior pituitary or the adenohypophysis, and it releases the growth hormone. Endocrine regulation, that means, for example, again you can quote the example of second example here you can quote is that regulation of the melatonin production from the pineal gland, circadian rhythm regulation, limbic system interaction, and the various, that is the temperature regulation and the feeding center and the satiety center. The here you can in this diagram we can see that the diencephalon, that means here we can see the hypothalamus. So here in this diagram we can see the bolo. Hello, hello, हेलो, हाँ बोलो। नहीं भैया, ये गलत बात है। आप मेरे को कल बोल दिए मैं मिल नहीं रहा हूँ, तो मैं तो मेरे कॉलेज के काम में लग गया। नहीं भैया, ये ऐसे काम करोगे तो मैं नहीं आऊंगा। हाँ बोलो भाई, चल रहा है अभी, बोलो बोलो। फोन काहे के लिए किया? हम लोग घर से निकलेंगे 5 बजे बाद। 4:30 के बाद का उनको बोला है, ताकि उस हिसाब से वो मानसिक तौर पर प्रिपेयर्ड रहे, इसलिए। हाँ मतलब, हाँ चलो देखते हैं। आप कहाँ पर हो अभी? तो आप तो बोले थे ना कि पास में जिनकी डेथ हो गई है वो। हाँ। कहाँ, शमशान? हेलो। अच्छा, चलो ठीक। So, sorry for the disruption, my dear friends. Again, in this diagram, we can see the diencephalon, the fornix, thalamus, hypothalamus, optic chiasma, pituitary gland, pituitary stalk, mammillary body, subthalamus, epithalamus. Epithalamus, in this, we see the pineal gland and the hadnula. The main thing which here we have to notice is the hypothalamus. Now, the simple diagram depicting the pituitary gland and the hypothalamus. This is the infundibulum, Rathke's pouch, oral cavity, notochord, and the infundibulum. Pharyngeal hypophysis, sphenoid bone, lumen of the diencephalon, optic chiasma, pars tuberalis, anterior lobe, pars nervosa, pars intermedia. Okay, this is the diagram showing the pituitary gland, optic chiasma, hypothalamus, sella turcica, that is the bone or the base of the sphenoid. This diagram is very much important. This diagram is depicting the divisions of the hypothalamus. Okay, anterior region, tuberal region, posterior region, mammillary body, third cranial nerve, tuber cinerum, lamina terminalis, optic chiasma, optic nerve, adenohypophysis, the tuberal part, distal part, intermediate part, the neurohypophysis part, the tuber cinereum, median eminence, infundibulous stalk, and the posterior lobe of the pituitary gland. I hope everything is clear. Divisions of the hypothalamus. This diagram is very much clear and depicting how the anterior hypothalamus is looking for next third ventricle, periventricular nucleus, paraventricular nucleus, anterior hypothalamic area, lateral hypothalamic area, supraoptic nucleus, and the suprachiasmatic nucleus, periventricular, medial, and the lateral nucleus. Now the middle hypothalamus. We from top to bottom we can see the lateral ventricle, thalamus, third ventricle, dorsomedial nucleus, ventromedial nucleus, lateral hypothalamic area, supraoptic nucleus, and the optic tract and the arcuate nucleus. I hope everything is clear. Now the posterior hypothalamus, lateral ventricle, thalamus. We are looking this diagram from top to downwards. Please have a very closer look to lateral ventricle, thalamus, third ventricle, posterior hypothalamic area, lateral hypothalamic area, and the mammillary body. Now the diagram of the hypothalamus again, anterior pituitary, adenohypophysis, posterior pituitary or the neurohypophysis, median eminence, arcuate nucleus, ventromedial nucleus, mammillary body, posterior hypothalamic area, dorsomedial nucleus, paraventricular nucleus, anterior hypothalamus, lamina terminalis, anterior commissure, preoptic nucleus, suprachiasmatic nucleus, supraoptic nucleus, optic tract or the optic chiasma, antipituitary or the adenohypophysis. I hope, my dear friends, everything is clear up till now. Now, coming on to the very important topic, that is the hypothalamic hypophyseal portal system. We can see the magnocellular neurons from the top, parvocellular neurons, okay, then the infundibular tract, hypothalamo-hypophyseal tract, which is shown in the bolder lines, inferior hypophyseal artery, hypophyseal veins, hypothalamo-hypophyseal portal system, superior hypophyseal artery. Okay. Now the very important topic, that is the functions of the hypothalamus, autonomic nervous system regulation. In this, we can see that the anterior area influences the PSNS through the projections to brainstem PSNS nuclei. Posterior area influences SNS through projections to the lateral gray horn. Hormone production. Magnocellular regions of the supraoptic and paraventricular nuclei produce oxytocin and vasopressin. Vasopressin, as we all know, the other name is the antidiuretic hormone, transported by axonal transport systems to the neurohypophysis. Axonal transport systems come under the hypothalamo-hypophyseal tract, released in the circulation. If there is damage to the supraoptic nucleus, there arises a condition called as the diabetes insipidus. Endocrine regulation, stimulating or the inhibiting hormones are transmitted via the tubuloinfundibular tract and released into the pituitary portal system and ultimately to the adenohypophysis or the anterior pituitary. Circadian rhythm regulation, input from the retina to the suprachiasmatic nucleus and then sent through the poorly defined projections to the pineal gland. I hope everything is clear. Now the various other functions. First is the temperature regulation. Posterior nerve conserve the heat, and posterior nucleus conserve the heat. Anterior nucleus dissipates the heat. Fever starts, that means sweating. Fever and that means chills. Feeding center, lateral nucleus induces eating. Ventromedial nucleus inhibits eating. Okay. Now the limbic system or the visceral brain mediates complex behaviors, that is preservation of the species, securing food, defense mechanisms, sexual behavior, emotions, affective behavior, memory, and motivation. Components of the diencephalon or the hypothalamus, singular gyrus, parahippocampal gyrus, mammillary body, hippocampus, anterior thalamic nucleus, amygdala, septal nuclei, dorsomedial thalamic nucleus. Again, I am repeating the components of the hypothalamus of the diencephalon. This is very much important. Kindly note it down. We can see the singular gyrus, parahippocampal gyrus, mammillary body, hippocampus, anterior thalamic nucleus, amygdala, septal nucleus, dorsomedial thalamic nucleus. Okay, moving on forward, we can see the corpus callosum in this diagram, anterior commissure, optic chiasma, amygdaloid nucleus, parahippocampal gyrus, hippocampus, mammillary body, fimbria fornix, anterior nucleus, medial dorsal nucleus, fornix, column, body, and crus, cingulum, cingulate gyrus, are just a part of the hypothalamus. Now, another part which is important, it is the Papez circuit. Okay, we can see the diagram in the diagram that from the cingulate gyre, anterior thalamic nucleus, there arises arrows to the cingulate gyrus, from the thalamus cingulate radiations. Okay, cingulum to the hippocampus, from the mammillothalamic tract, from the mammillary body again to the anterior thalamic nucleus, and in that comes there the fornix. Okay, here it is a diagram of the fornix. Okay, understood. Now The amygdala, located deep to the uncus near tail of the chordate and above most rostral part of the lateral ventricle inferior horn. Wide variety of functions and connections like lip smacking, lip smacking, chewing, autonomic responses, fear, rage, anxiety, etc. Placidity, visual agnosia, oral tendencies, and hypersexuality are also there. And there is a syndrome which is called as the Clover Bucy syndrome. Thank you and wishing you all the best.